Hello, grade 11. This is what I'm hoping we can cover today in today's class. We've mentioned before that a quadratic can be written in three different ways: polynomial format, ax squared minus plus bx plus c, which is the first one here, the factored format, and the completed square format. And each of these have a purpose that we can detect. And so in polynomial format, when we substitute x equals 0, we find that the y-intercept is at negative 24, and we can read that straight from the polynomial form. The y-intercept is at negative 24. From the factored form, we solve each bracket equal to 0, which makes it easy to see that the x-intercept is either at negative 2 or the x-intercept is at 4. When you substitute these numbers, when we substitute 4 in there for x, we get 4 minus 4, which yields that bracket value is 0, and therefore the whole equation is worth 0, having our x-intercepts therefore negative 2 and at 4. In completed square format, we read the coordinates of the vertex. The coordinates of the vertex are 1. So when we substitute 1 in here in the bracket, we get a 0, which is the smallest square number, therefore the minimum value of y. So the x-coordinate is 1 and the y-coordinate is negative 27. So these are values that we can read directly from the format, each of these formats. Okay, so we can now draw the graph. If I draw our x-axis and our y-axis, and I notice the y-intercept is at negative 24. The vertex is at 1 minus 27. Let's put that there. And the two x-intercepts occur at negative 2 and at positive 4. And then we can draw the parabola. Something like this. There we are, that's my x-axis and y-axis. So having the three forms is nice because each form gives us something to do with the graph. However, it's also true that regardless of which form you have, you can calculate all of these three features from any of the forms. And that's what we do here on this page, is we make connections between the three forms and the three special features. So first, let's look at the y-intercept. The y-intercept we calculate by setting x equal to 0. We can do that regardless of the format that we're giving. So in the first one, we've got 3 times 0 squared minus 6 times 0 minus 24. And we calculate that to be minus 24. In the second format, we again substitute x equals 0. And so we get 3 multiplied by 0 plus 2, which is just the number 2, multiplied by 0 minus 4, which is the number negative 4. 3 times 2 is 6. 6 times negative 4 is negative 24. And finally, in the last form, we substitute 0 again. We get 0 minus 1 squared minus 27. And so we have 3 times positive 1. Minus 27. Minus 27. And that's 3 minus 27 is minus 24. So regardless of whether we start with the polynomial form, the factored form, or the completed square form, we get the answer negative 24, always by substituting 0 for the x-coordinate. Okay, so the x-intercepts. Again, it doesn't matter which format we start with, we can find the x-intercepts if they exist. Now, looking at the graph we drew up above, I know they do exist. They exist at negative 2 and 4. And we can find that whether we have the polynomial form, or the factored form, or the completed square form. So the factored form is the easiest form because we just substitute 0 for the y-coordinate, and I need to find two numbers, a number for each bracket that will return the value 0 for the bracket, and therefore anything multiplied by 0 gives the answer 0. So we have 0 equals x plus 2, or 0 equals x minus 4, or 0 equals 3, which doesn't make any sense, so 3 is not a solution. Subtract 2 from both sides, and we get x equals minus 2. And so add 4 to both sides, and we get x equals 4. And so the factored form is the easiest one to find the x-intercepts. However, we can also do it if we've gotten in completed square form. We substitute 0 for y to find the x-intercepts. We're expecting to have two answers, so that's a 27. Add 27 to both sides, we get 27 equals 3. And this is lovely because both sides have a factor of 3, so divide both sides by 3. We get 9 equals x minus 1 all squared. Again, this is lovely because 9 is a square number, so when we take the square root of both sides, we get plus or minus 3 is equal to x minus 1. And finally, we add 1 to both sides. So x is equal to plus or minus 3 plus 1. In other words, the first one is minus 3 plus 1, which is minus 2. And the second answer is plus 3 plus 1, which is 4, agreeing, of course, with the answers we already got here. So we can solve for 0, whether it's in factored form or in completed square form. And again, we can do it with the polynomial form either by factoring it, or by completing the square, or by using the quadratic formula where we set a equals 3, b equals minus 6, and c equals minus 24. And then we calculate b squared minus 4ac, which is b squared is 36, positive 36, minus 4 times 3 times minus 24. And we get 36, 288, which then gives us, I'm going to have to get the calculator out, 324. And so when we take the square root of 324, it's 18. And so now applying the formula, we go x equals minus b plus or minus all that. And of course we get negative minus 6. 6 plus or minus the square root of 324, which is 18, divided by 2 times a, which is 6. All of that simplifies. We've got 1 there, and we've got 3 there, and we get 1 plus or minus 3, and so x1 equals 2, and x2 equals 4. Okay, so no matter which format we start with, we have a method for finding the x-intercepts. We could use the quadratic formula, or factor it first, solve by factoring, or complete the square first, and solve after completing the square. It's given in completed square form, no need to multiply it out, but if you do multiply it out, it's going to work out. It just takes a lot more lines. Alright, finally the vertex. Now, since we've already got the x-intercepts are at negative 2 and at 4, one method that we've used before is to add these together and find the middle of them. Add the roots together. If the roots are here and here, the vertex is going to be halfway between. So we find halfway between negative 2 and 4 by adding them and dividing by 2. So we get 2 divided by 2, which is the number 1. And so x vertex is 1. Now we know where the x vertex is. We can put 1 into our formula and calculate for y. So y is equal to 3 multiplied by 1 plus 2 multiplied by 1 minus 4, which is 3 multiplied by 3 multiplied by negative 3, which is minus 27. And so our vertex has coordinates 1, minus 27. Okay, so that's what we did in one of the first ways that we solved to find the vertex. We also said if it's in completed square form, that is the form a multiplied by x minus h all squared plus k, that the h and the k are the coordinates of the vertex. The vertex is at h, k. H is the value that if we substitute x with that, h minus h, the bracket is worth 0. And in this case, our h value is 1, and our k value is negative 27. So the vertex is at 1 minus 27. No calculation required, just straight to it using the completed square form of the parabola. All right, and finally, starting from polynomial form, we have a new formula which comes from adding the two solutions together like we did from factored form. But if our solutions are x1 equals minus b minus the square root of b squared minus 4ac divided by 2a, and our other solution is minus b plus the square root of all that divided by 2a, when we add these together, it turns out this negative and this positive cancel each other out. And so our formula for a vertex is very simple. Coming from adding them together using the quadratic formula, we have x vertex is minus b divided by 2a. In our case, a is equal to 3 and b is equal to negative 6. So x vertex is minus 6 divided by 2 times 3, which is negative minus 6 is 1, and sorry, is 6, positive 6, and 2 times 3 is 6. 6 divided by 6 is 1. And once we found out the x-coordinate of the vertex, the y-coordinate we find by substituting the value x into whatever form of formula we like. We can substitute the 1 in to the polynomial form, or to the factored form, or to the completed square form. And we get, in polynomial form, we get 3 times 1, which is 3, minus 6 times 1, minus 24, which is minus 27. And again, all our answers for this agree. 1 minus 27, 1 minus 27, 1 minus 27, they agree regardless of which technique we use, or which form of polynomial that we start with. Okay, that's making connections for all the special features of a parabola.